Good morning, student. Today we will start unit number 3. The title of the unit is Machine Learning. In this unit, we will discuss about what is machine learning, the types of machine learning, and we will discuss different types of techniques of machine learning. So first of all, let's discuss what is machine learning. So machine learning is basically a programming which is used to optimize a performance criteria using example data or past experience. What does we mean by that? In similar with humans, we usually have a tendency to learn from the past experiences. Similarly, on the basis of that, machine learning use past data and try to optimize the performance. Because as we know, day by day, the data is increasing and humans don't have a capability to handle this huge amount of data. So for that purpose, we need machine learning techniques to automate this and to handle the past data and to optimize the performance criteria. For that purpose, we use a model building. Okay, we have a model defined up to some parameters, and learning is execution of the computer program to optimize the parameter of the model using the training data or past data. So we have the model. In this model, certain parameters are attached. We have to train that parameters based upon the training data, or you can say the past experiences. As soon as we'll optimize the parameters, we'll get the good results. We have basically two types of models. The one is predictive models and the another one is descriptive one. Predictive models are those which are used to make the prediction in the futures, and descriptive models are those which are used to gain the knowledge from the data. There are certain models which have the combination of both predictive and descriptive ones. So now the first concept is, what is learning? Learning, a computer program is set to learn from the experience, capital E, with respect to some class of task T and the performance measure P. If its performance at task T as measured by P improves with experience E, then it is called learning of the system. What we mean by this? We mean that from the experiences E, you need to perform a task T, and depending upon your performance measure, you have to improve your experiences. Okay. A computer program which learns from experience is called machine learning program, or simply a learning program. Such program is sometimes also referred to as a learner. Why we call it learner? Because they are learning the things from the past experiences. Okay. There are certain examples. The first example is handwriting recognition learning problem. So this is an objective function. What is the task? Here the task is recognizing and classifying the handwritten words within the image. So in the data sets, we have lots of images in which handwritten characters are written, and you have to recognize what is a particular character and in which class it will lie. The performance measure P is percent of the words correctly classified. It means from the data set, how much data you can correctly classify. The training experience E is the data set of the handwritten words with given classification. Okay, so in the training set E, what we have? So in the training set E, we have a data set in which handwritten characters, words are given. We have to recognize these characters based upon how much characters are correctly classified. Similarly, there is another problem, a robot driving learning problem. In this, the task is driving on highway using the vision sensors. This is the objective function. The performance measure is a average distance traveled before an error. And the training experience, capital E, is the sequence of image and steering commands recorded while observing a human driver. So basically, we are using the capital E, all the values which is provided on the capital E, we will use those values, will define how accurately the objective function will meet, depend upon our performance measure. Okay, and we need to satisfy the task T. So this is in components of the learning. The basic components of the learning process are divided into 4 parts: data storage, abstraction, generalization, and evaluation. In data storage, we'll have data. In abstraction, we'll define the concepts. Generalization will we will actually extract out the inferences, and finally we will perform the evaluation. So let's discuss these concepts one by one. The first one is the data storage. The facilities for storing and retrieving huge amount of data are an important components of the learning process. Human and computers alike utilize data storage as a foundation for advanced reasoning. Okay, so for taking any decision, you will need lots of data. So for that purpose, you need a storage capacity. So data storage is the first part of the machine learning process in which you will store all type of data. So in a human, the data is stored in brains and data is retrieved from the electrochemical signals. But in computers, we use hard disk, flash memory, random access memory, and similar types of devices to store the data, and use cables and other technologies to retrieve the data. So this is the first step of machine learning in which you will store the data. The second component of machine learning is your abstraction. So abstraction is a process of extraction knowledge about the stored data. So now you have the data. From the data, you need to extract the knowledge. This involves creating general concepts about the data as a whole. The creation of knowledge involves application of known models and creations of new models. The process of fitting a model to a data set is known as training. When the model has been trained, the data is transformed into an abstract form that summarizes the original information. Actually, whatever data you have stored, that is a very raw data, or you can say unprocessed data, and it will have a huge amount of columns and row values. Maybe all the column values and all the rows values are not important towards your application. So for that purpose, you need abstraction. What abstraction do? The data which is defined in a raw format, you will convert into that format that is valuable for your application. Okay, so like you have to perform certain kinds of coding to the data. You need to minimize the sometimes suppose the address field is there, then you can perform a certain kind of coding to define the address. Like you have to do lots of transformation on that data to present a data in such an abstract way that the original information will not lose, but the original information is visible in much more clear way. After abstraction, the third component is the generalization. The generalization describes the process of turning the knowledge about the stored data into a form that can be utilized for future actions. These actions are to be carried out on the tasks that are similar but not identical to those that have seen before. Okay. So in generalization, the goal is to discover the properties of data that will be most relevant to the future task. Okay, so after presenting your data in an abstract form, we'll use the generalization, which can help to solve the similar kind of application, similar to the data for the application where you store that data. After generalization, we'll do evaluation. This is a last component of learning process. It is a process of giving feedback to the user to measure the utility of learned knowledge. This feedback is then utilized to effect the improvement in the whole learning process. So this is your learning process. Like first one is a data storage, then abstraction, afterwards generalization, and then evaluation. At the evaluation stage, you will check whether the final data you will receive is appropriate for it or not, appropriate for your application or not. If it is not appropriate, then the feedback is taken and then we'll further utilize this feedback for the improvement of whole learning process. Like we'll go back and we'll trace out where the mistake is occurred. Now more type of coding is required. The coding is means to make your data in a simpler way. Like suppose you have a gender denotation in a data set like male, female, and transgender, you can simply denote 1, 2, 3. Then this will compact your storage size where you are storing your data. Similarly, suppose you have a house owner or you are a car owner, you simply denote your data set from by just 1 or 0, where 1 will show you're having a car and 0 shows you don't have the car. So these types of transformations are applied to the data before processing. After that, we'll have the learning models. After learning, we'll use learning models to apply on the data. The machine learning is concerned with using the right features to build the right models that will achieve the right task. The basic learning models are divided into the following categories. The first one is using logical expressions, the logical models. The second one is using the geometry of instance space, geometric model. Then using the probability to classify the instance space, probabilistic model. And the fourth one is grouping and grading. Grouping and grading is depend upon the first three actually. So these are the three categories you can say, and the grouping grading is a combination of above three. So any learning model can be categorized in these major divisions of your learning model: logical model, geometric model, probabilistic model, and grouping and grading. Let's discuss all these models one by one. The first one is the logical model. So logical model uses a logical expression to divide your instance space into segments and hence construct grouping model. A logical expression is an expression that returns a Boolean value. Boolean value means either true or false. Once the data is grouped into the logical expression, the data is divided into the homogeneous grouping of the problem we are trying to solve. For example, like classification problem, all the instances of the group belongs to a single class. So we have two types of logical models. The one is tree model. The next one is your rule model. Okay, so classification type of applications are lies into the logical model in which a logical expression is given. On the basis of that logical expressions, what we are calculating? We are calculating the result of the expression is either true or false. If it is true, it will move to a branch of the tree. If it is false, then it will move to the another branch of the tree. So we'll have mainly two types of model, the rule-based and the tree-based. In the rule-based, we'll form the rules using the decision control statements like if, then kind of things. And in the tree, we'll use if part, then part. Then we have the branches of the segments. So these are the logical model. All the classification lies into the logical models. In the logical model, we use the use concept learning for that. The concept learning is the inferring of the Boolean valued function from the training example to its input and output. Like here you can see there are certain attributes and a concept is given. The value of concept is either yes or no. So you can say it's a Boolean value, either yes or no. Whatever will be the value of attribute, at last we will receive a Boolean value, either yes or no. Let's take the first instance where the sky is sunny, air temperature is warm, humidity is normal, wind is strong, water is warm, forecast is same. Then enjoy the sport is yes. Similarly, as instance number 3 will receive a concept that is no. Okay. So depending upon these attribute value will either lie to the one side or to the other side. At the last, will have only the Boolean values. At the leaf node of the tree will have the Boolean values. Similarly, at the last value of any rule will have a concept value. The another type of model is your geometric model. In a geometric models will represent the functions into dimensional spaces like x and y space or the three-dimensional space x, y, z space. Okay. So in this, all the features are defined geometrically into the instance space and we are trying to fit the lines there. Okay. To fit the lines or planes, we'll have the linear models. For example, regression. And to represent your geometrically similar points similar to each other, for that purpose, we'll use distance-based model. The commonly used distance measures are Euclidean distance, Minkowski, Manhattan distance, Mahalanobis distance. Okay, so these are the 4 distance measures that are frequently used to measure the distance between the 2 points. And if the distance is minimum, then we can say the 2 points are similar to each other. These models are usually used in clustering types of application like K-means clustering or the nearest neighbor, in which all the data sets are represented in the form of instance space, like in the form of geometry. And then we'll try to either fit the lines or planes, or we try to find out the similar clusters, the points which are closer to each other. The third type of model is your probabilistic model. The probabilistic model sees features and target values as a random variable. The process of modeling represents and manipulates the level of uncertainty with respect to each variable. So we have 2 types of probabilistic model. The one is predictive and one is generative. In the predictive probability, we'll consider a conditional probability. If X exists, then the Y exists. And in generative models, we will use the joint probability of the existence of Y as well as the X. Okay. So in the latter one, both will execute similarly. Like Y exists, then X also exists, joint probability. But in the conditional probability, how many times X will occur, then Y will occur, this condition. So naive Bayes is an example of your probabilistic classifier. This model depends upon the probability, will consider the probability, will calculate the probability, and then we will decide how to categorize the data. The fourth one is grouping and grading. In grouping and grading and grouping is an orthogonal categorization to the geometric, probabilistic, and logical compositions. All the above three divisions can be combined together in grouping and in grading also. Okay. So grouping model breaks the instance space into groups and segments, and each segments apply a very simple method like majority classes, decision tree, KNN, all these. And grading models from one global model over the instance space. The example is linear classifier similar to the neural networks. Okay, so we are generalizing these models and will group together or will grade together. So this is the fourth classification of your learning models. Then designing a learning system. To design a learning system, you need to evaluate T, task, P, performance measure, and E, training experiences. Okay, so from the training experiences, like we have an unknown target function where X tends to Y. Like you need to evaluate a value of Y depending upon the function X, which is applied to the value X. Okay, so for that purpose, we'll take lots of training examples, like in which the input value X is given and the output value Y is also given. So we'll take certain combination of these input and output. We'll give these combinations to our learning algorithm. From the learning algorithm, first we generate a hypothesis, then we'll apply a hypothesis also, and then we'll get a final hypothesis. And F is equivalent to your G. So this is your design of a learning system, in which first you define the task T. Task T is your unknown target function. Training example is your capital E, where you have the input output combination. Performance measures are basically help to calculate the performance of your learning algorithm, and you will form a hypothesis, and then you will test the hypothesis whether your hypothesis is true or false. Then we have the types of learning. So we have three types of learning: supervised learning, unsupervised learning, and reinforcement learning. So for supervised learning, we'll have a training set of example with the current response is provided. Okay, so you have a training input values as well as the output values. Based upon those input and output mapping, we will train our data. Okay, so this is also called an exemplar. Supervised learning is a machine learning task of learning, a function that maps an input to output based on the example input-output pairs. So first you will have, suppose, an input raw data. Look into the picture. You will have the input raw data. From the input raw data, that will use an algorithm here. Then this algorithm is take the value from the training data and the desired output. So we have the combination of like x1, y1, x2, y2 to xn and yn. Okay. So based upon this, so from this point, we'll have the supervision here. Okay. So by using this supervision, our algorithm will train ourselves. Okay. So algorithm from the mapping of input and output, the algorithm will be trained. After training, we'll process the new data and new data. The trained model is now capable to handle any new data to categorize into a set of defined output values. Okay. So here you can see the three outputs are there. If you provide any new data to this trained system, then it will categorize your input data into any of these three output values. So this is your supervised learning, where you have target value in front of you. Based upon the target values, will train our model. Like the example is, you can look at this table. Here the two columns are given, gender and age. These are the X values, and the label is, you can say, this is a Y value. Like if a male age is 48, then it is 6. The male age is 67, it is 6. The female, the age is 53, it is healthy, like this. So we have the two output values, sick and healthy, and two input values, gender and age. So we have the combination of these input and the corresponding output value. The next one is your unsupervised learning, in which there is no target output value. Okay, you have only input data with you. Based upon your input data, you need to form the certain clusters, like male 48 is given, male 67 is given, female 53 is given. So you will have only input values. There is no target value in front of you. Now you have to categorize into certain groups to find out the relevant clusters. The third type of learning is your reinforcement learning. It is somewhere between the supervised learning and unsupervised learning. Reinforcement learning is the problem of getting an agent to act in the world so as to maximize its reward. Okay. So here in reinforcement learning, actually there is no supervision. You don't have any, like you can score the answer, but you cannot suggest the improvements, what improvement it could take. But you have a certain output value that will help to map your input output combinations, but there is no feedback. So this is a complete chart of your model information. Like if you have the model information which is complete, then you can apply Bayes decision theory. If your model information is incomplete, then it will further categorize into two parts, supervised learning and unsupervised learning. Then further, the supervised and unsupervised learning is divided into parametric approach and non-parametric approach. If your model information is incomplete and supervised, like you know the target values, and it is the parametric approach, then we can apply optimal rules and plug-in rules. And if we are using the supervised learning and non-parametric approach is used, then we can use the density estimation and genetic rules, KNN and MLPs. If the model information is incomplete and unsupervised learning is used and your approach is parametric, then you can use the mixture resolving. And if the non-parametric approach is used, then you can use the cluster analysis like hard and fuzzy clusters. So this is the chart will show if you have a problem, you need to first analyze which of the method you are going to apply on that data. So first you need to find out whether you have a complete information or incomplete information. You are going to apply supervised learning and unsupervised learning. Then this will help you to identify which method could be applied on your application area. That's all with today's lecture.